Hello, everyone. This lesson is about solving exponential equations with a common base. So I'll be showing you about 3 examples today. All right. So what is a base? Okay, so the base is the large font number. It does not mean a large number. It means the large font number. Okay, so a common base, sometimes there's a clue. One of the numbers might help you out. So we're going to try to make 27 a power of 3. Okay, so you might already know that 27 is 3 to the 3rd power. You could reference a chart and do 3 to the 3rd power is 27, or you could use a calculator. So we're going to write this number 27 right here as 3 to the 3rd power. Okay. And then we could solve the problem easily. 3 to the 3rd, keep that in parentheses, recopy the exponent, and then keep the right-hand side the same. Once you have the same base, you're able to then set the exponent portions equal. However, first you need to distribute this 3 by these 2 terms. So that would give you 3 to the 3x plus 12 equal to 3 to the 2x plus 5. So as I said before, you could set these equal because you have the same base. So that's how you solve this type of exponential equation. Then you have pretty much an algebra 1 problem. All right. So subtract 5 to isolate, you get 3x plus 7 is equal to 2x. Subtract 2x, subtract 2x, you get x. Bring the 7 over, so you get -7 is your answer. Okay. So once again, I wrote 27 as a power of 3. That was the common base. I distributed, got 3x plus 12. Set the exponent portions equal and got -7. All right, let's move on to our next example. So this example is pretty much the same, except it's slightly harder because there's no clue as to what the common base is. So again, we need common base as the theme. All right. So we have 16 and 32. I'll start with the smaller number, so 16. So you can look on a list here. I could do Control F for find, type in 16 if you want. It appears several times. It'd be 4 squared, 6 to the 3rd. Sorry, not 6 to the 3rd. It'd be 4 squared or 2 to the 4th. My guess would be 2 to the 4th. So let's do that for now. So we're going to write 16 as 2 to the 4th. But then 32, we need to look up or use a calculator, or you might know this in your head. 2 to the 5th power. All right, so the rest is easy. We have 2 to the 4th, then we have the 2 to the 5th. So we now have a common base. Then the next step you would do is distribute the exponents. So you have 2 to the 12x minus 12, and 2 to the 10x minus 20. Set the exponents equal, because that's a property that we're allowed to do. All right. Then isolate x, so I'll add 12. Add 12, I get -8. I'm going to subtract 10x simultaneously just to save space. So that would give you 2x equals -8. Divide by 2, you get x equals -4. All right. So again, the common base was not as clear as the last example, but you use your chart or your intuition. This was powers of 2. Then I distributed the exponents. and then I solved a multi-step algebra 1 problem. All right. The last example I have for you is pretty much the same, except you have a negative exponent. Okay. So remember, when you have a negative exponent, you have to flip the base. So if you're given a number that's flipped, in this case, the 256 is flipped, you're going to have some number to a negative exponent. All right. So let me work with that. Screen's not cooperating. Give me a second. There we go. Okay, so let's work with the smaller number. So the 64 would be easier. So 64, you could search, you could use a calculator, would be 4 to the third or 2 to the eighth. My guess will be 2 to the eighth. So let's see if this is going to work out. But then you want to see if 256 would be 2 to some power. All right, so I'm going to pull up a calculator. 2 to the sixth, 64, you need to go higher, maybe 2 to the eighth. So it's 2 to the eighth power. Now, remember, if you have 2 to the negative 8, that means 1 over 2 to the 8, which is 1 over 256. So in fact, the problem becomes sorry, this is a mistake. The left-hand side should have said 2 to the sixth. Problem becomes 2 to the sixth equal 2 to the eighth, negative eighth, as I just mentioned, because you have to flip the base, which would produce this fraction. Okay. So then you distribute the exponents, as I did in the other examples. So you get 2 to the 6x minus 12 equals 2 to the negative 8x. 8 times 12 would be 80, and 16, negative 96. So then you could set the exponents equal 6x minus 12 equal negative 8x minus 96. So then I'll add 8x is one way to do it. Save steps, I'll add 12, bring that over. That would be 96, and 12 would be negative 84. 14x. Then you divide by 14, which probably be a decimal, but I could be wrong. 84 divided by 14 actually works out. It would be negative 6. So that worked out as an integer answer. All right. So once again, if you have different bases, I like to work with a smaller number or number that's not a fraction. Again, this is 2 to the sixth. I made an error before. Negative exponent means you flip it. I use the calculator to get 256. It was 2 to the eighth, and the rest just follows suit. Thank you. Hope you learned how to solve exponential equations by using a common base.